Hello, Laya. Can you hear me? Am I audible, Laya? Hello. Can you hear me, Laya?
Yes, sir. Can you hear me?
Yeah, I can hear you. Okay, welcome. Let's start today's session. Let me share my screen.
Yes, sir.
Okay, so last class uh, we studied order, we studied degree, and we were looking into solutions, general and particular solutions. So let's quickly recap all that. So what was order of the differential equation?
Sir, can you hear me?
Yeah, I can hear you. Can you tell me what was the
Yeah.
order of the differential equation? How can you
Was it
define
the highest? Yeah, was it the
highest?
highest differentiation?
Yeah,
Like the
highest
highest
order
order of the
of,
differentiation?
yes. So order is the highest order of differential or differentiation of independent variable will depend to all that. That's the order. And what is degree of the differential equation?
Is it the power of the highest order?
Yes. So it's power or exponent of the highest order, whichever we are looking in the differential equation. So uh, we we just did some basic problems yesterday. Now let's day before tomorrow. Let's do some of the tough questions now. So one thing that should be kept in mind while looking for degree is that degree. Let's first check what degree is in case of a polynomial. So if we see a polynomial, so do you remember uh, any like conditions that must be followed to check whether a degree is valid or not?
I don't think so.
Can you tell me that is this a polynomial? 1 upon x plus x square plus x cube equals 0. Is this a polynomial?
Um, I
Yeah,
think so.
we can change it. But if I yes, this is a polynomial. We can just change it into
Okay.
polynomial. But if I do this, let's say I would one of the exponent is negative. So then we cannot say that it is a polynomial because there is only one condition for an expression to be a polynomial or not. Let's say this is fx not equal to 0, then it's okay. So there is only this one condition that degree must be a positive integer. Anything else in the degree, then we will say that the given expression is not a polynomial. So let's check
Okay.
if uh, we can write this as x raised to the power minus 1 plus x square plus x3 if we're conditioning the plus 1. So here we can see the degree is negative. So this is not a polynomial, right?
Yeah.
Let's say if this is positive, but we have 2 over 3 here, then again 2 by 3 is not a positive integer. Positive integers are those which are shown on the number line, plus 1 plus 2, and we are looking at positives, so plus 1 plus 2 and so on. So anything other than these numbers in the degree, then we say that the given expression or function is not a polynomial function. Similarly here, what we are doing is we will check if the given equation that it is written that the derivative, we are only going to look for the derivative and all the derivatives present in the equation, that their degree must be a polynomial function. So the derivatives that are present here must be a polynomial function. So if we
Yes, sir.
see here, we have a term log dy by dx. So this is not going to make it a degree, because log function can be expanded as 1 plus x square plus and so on, x cube by 3 by 2 factorial. So how can we say that dy by dx is just of degree 1, right? You're getting my point,
Hmm.
because when you expand
Yes,
that,
sir.
you get dy by dx square, one term and something here, then you get dy by dx whole cube. So there is 2 degree, there is 3, and so on. So we cannot say that here degree exists. No
Yes, sir.
degree. This differential equation will have no degree. So you have to check, like, if you're going to find degree and you see that the dy over dx term is inside some function, let's say trigonometric function, sine or cos, tan, any other, and let's say if it's a logarithm function, log function, or an exponent function, e raised to the power dy by dx, all these cases will tell you that degree does not exist. Okay, sometimes they ask this questions where they will give you equation, and one of them will have definitely have a term in it where the degree does not exist. So it's good to know this.
Yes, sir.
Okay, so let's quickly solve all these. And okay, so the first one is d2y. So which is the, so here, can you find order here? Yes, we can find order. Order is just second order. The highest differential is d2y, so order is 2.
2.
And degree does not exist.
3. Oh, does not exist. Yeah.
Okay, so let's see this one. Will the degree exist here?
Um,
See, if you just look at this right now, this looks like not a polynomial. The thing that we learned in not a polynomial, because there is a function that 1 over dy by dx. If you write this at 5 dy over dx, then you will get an exponent of -1, right? We have
yes,
to
sir.
check for dy by dx every time. So if we convert uh, the term here dy by dx, we'll get -1 in the exponent. So this looks like it's not
So we
a
don't have a degree.
so first of all, we're going to modify it a little bit. So let's change it a little bit. So what we can write, so let's multiply by dy by dx over the both equation, right? Because we have a term here 1 over dy by dx. So if we multiply the equation completely by dy by over dx, this dy by dx will cancel out. So let's write dx
Oh,
3x dy by dx. We are multiplying this term by dy by dx. Next is 5 over dy by dx. We are multiplying this whole term by dy by dx. Next is y cube, and we'll multiply dy over dx here also. So now we can see that this dy by dx will cancel out, and this dy by dx will become 3x dy over dx to the whole power 2, right? It's just squaring. The same thing is multiplying again. Next is 5 equals y cube dy by dx. So now if asked what is the order and degree, so here we can see order is what? Order is just 1. We have only one
1.
first order derivative present. And what is the degree? The degree is 2, because the
2.
highest power is 2.
Okay, sir. Got it.
Okay, next let's, so all of these are just the different examples of all the types of order and degree questions I could find out. So let's do third one. Do you have a notebook with you open or
Yes,
anything?
sir. Yes, sir. I have
Yeah,
notebook.
so can you try out third one and quickly tell me the answer?
Okay, sir. One second. So should I take the square root off? Hello, sir. Sir, can you hear me?
Rohan, you're not audible. Please unmute yourself.
Oh, sorry. Am I audible now? Yeah.
Yes, I saw
So
that.
can you walk me through the steps what you did? What you just saw in the question was wrong. What was the first modification that you did?
I thought I should take the square root off.
Yeah. So first thing is the same thing that if you have a square root is what? Square root is exponent of 1 over 2. If you have square root of x, that's equivalent to x raised to the power 1 by 2. So here we can see the exponent of a derivative is going to be a fraction, which is not allowed. So we need to remove this square root first. So how we can remove
Yes,
square
sir.
root? We can square both sides. Like, so did you square?
Yes, sir. I squared both sides. So it's
Okay.
y square
Y square,
equal to x square dy by dx square
y square equals x square dy by dx square plus you'll get a square times 1 minus dy by dx to the whole square, and you get an additional term of 2ab. That's 2x dy by dx into a square root times the term. So this was the
Yes,
first
sir.
approach. Okay,
Yes,
so
sir.
see, the approach was correct, but if you do this like this, you'll get stuck here. You the last term, that 2ab term, you'll get a square root again, right?
Yeah.
So instead of doing just squaring, what we can do, we can first take this x dy by dx term over to the left
To
side.
the other side.
So yeah,
Okay.
so that this square root term is the only term in the right hand side, and when we square both sides, we don't have to apply the formula for whole square to this square root, right? So we don't
Okay.
get this term. So let's do this. So first let's take this x dy by dx over to the left hand side. So this is x dy over dx gives us a root 1 minus dy by dx to the whole power 2. Now we can take the square both sides to get y square plus x square dy by dx plus 2
Square
minus
minus
2xy.
2yx dy by dx
Yes, and right
is
hand
equal
side
to
we get
x square.
x 1 minus dy by dx to the whole power 2.
Isn't it a square?
Yes, that's a square.
Yeah.
So this is what we get, and we can see that the now there is no derivative present in the equation which have an exponent of, which have a radical expression,
Minus. Yes.
exponent. Radical means it's not in root, or it's not in power 1 by fraction. So everything is now a positive integer. Here we have dy by
Yes,
dx,
sir.
it's 2, here also, here also. So now we can check for order and degree. So what is the order?
Order is 1 and degree is 2.
Order is 1 and degree is 2. Right, so degree is here 2. Here also we have degree 2, so we can take degree 2. So similarly this one can be done. Next one, fourth, right?
Yes,
Here
sir.
we have only the square root on the one side, so we can just square both
So
sides.
square the both
So what
sides.
will the order and degree?
So we,
We can do this directly, like this square will be cancelled out and we'll get a whole square of dy by dx over in the right hand
yes,
side.
so it'll be order 1 and degree 2.
Yeah, so let's do this once to be sure completely. So there is a little twist in this question. That's why we are doing this.
Okay.
So let's square both sides to get 1 plus, oh, sorry, 1 plus dy over dx to the whole square gives. Now squaring this sides, we get 9x square plus dy over dx square minus 6x dy by dx. Is it correct?
Yes, sir.
Okay, so now we can see that the term dy over dx and dy over dx to the whole square cancel out from both sides, right?
Oh,
Because it's
yes.
the same. So now what we are left with, we are left with only dy by dx.
dy
So
by
what is
dx.
order and degree? Order is 1 and degree is also
1
1.
and 1.
So that's why we are always going to change the equation into an valid acceptable equation. What is valid acceptable? That the derivatives present must not possess an radical exponent in their exponent, right? Like the exponent should be a positive
Yes,
integer
sir.
always. Then we are going to look for, we can look for order earlier also, but degree definitely will look when every derivative has a positive integer in its exponent. So let's quickly do this one, last one. So what is the order and degree here? Will it be, will the degree does not exist because we have a log x term? Similarly, here we had a log term and we said degree does not exist. So we can say that here too.
No, sir, I don't think so because it's log x.
Yeah. So we are only going to check the derivatives, that is dy
dy
over
by
dx,
dx, yeah.
and not any other term that can exist. But we are only going to check dy. So what's the order and degree here? Order is,
So order is 2
yes,
and
and
degree is 1.
degree is 1, right? So I had answers here. Let's see, 2 1 1 2 1 2 1 2 1 2. Okay. So now we'll move on to our next part, which was verifying that a given value of y is a solution of some differential equation. So here we are
Yes.
going to learn two new things. Uh, there are two methods in which this question can be completed. First is that you have the value of y, you can determine the value of y dash, or this y1 means y dash. There are three different ways of representing the derivatives. First is dy by dx, second is y dash, and this is also can represent as y1, right? And if it's
Yes,
function,
sir.
you can represent that f dash x. So the first thing is you can substitute the value of y in this equation and the value of first derivative to simplify the left hand side, and further we simplify, and somewhere we get y square equal to y square. So we say that this is the solution. The next form is what you can do. You have a value of y, so you can eliminate the, you can see the in the differential equation we do not have anywhere a is not present anywhere. So what we can do, we can simplify this y so that the final simplification does not contain this arbitrary constant a. Okay, then we will
Yes,
have
sir.
our equation like this, and we'll say that yes, this is the equation that we were looking for. So let's do this. Let's differentiate. So, so you have to really think here, like if we differentiate it just like that, let's say y dash is differentiating this side. So this is x plus a raised to the power minus 1. So we'll get minus a upon x plus a raised to the power 2. So you see here, no matter how many times we differentiate, we're going to increase the power. Okay,
Yes,
so
sir.
the correct approach here is to first just cross multiply it to get y times x plus a equals to a. Okay, let's call this our equation 1. Now we'll differentiate equation 1 to get, this is a, this will be done by the product rule. So you get y times the differentiation of x plus 1, x plus a is 1, plus
1
x plus a times the differentiation of y is dy over
dy
dx,
by dx.
and the differentiation of constant is just 0.
0.
So now we have something equation like this. So next, what we need to do, to make this y look like this differential equation is we need to replace these two a's. So first of all, we have the value of a here. We can substitute this directly, and we can
Yes, sir.
determine the value of x plus a from here, because we can see that x plus a is just lying here. So we can solve this for x plus a. So x plus a times dy by dx is minus y, and x plus a is minus y by, let's write is at y1, which is required in the question. So this is the value of x plus a minus y over y1, and this is the value of a, that is y times x plus a. Now let's substitute both of these values in the given value of y to get y equals y times, or we can just uh, okay, we have to make this, we are substituting a, let's determine a from here also. A is minus y over y1 minus x. Now let's use these two values. So we'll get minus y over y1 minus x whole divided by x plus a is minus y over y1. Okay, we have to solve this. Let's make some room. Oh, okay, we have to do that again. What was dy by dx? Let's do this again. X plus a times y is a, and y plus x
So it
plus
was y is
a
equal
y
to
dash.
minus
Yes,
y.
so this is 0, and y dash is minus y. We're going to solve for x plus a, and y dash is minus y by x plus a.
So isn't it the other way around?
Yeah, you can do it both ways. Like you can substitute the value of a, and you can replace these arbitrary constants in form of y dash, y double dash sometimes. And uh, the other way is you can just substitute the value of y1 derivative by determining the derivative of this, and just solving the left hand side to get the value of y. Both ways are equally, like you can do it both ways.
Okay, sir.
Okay, so let's quickly substitute. Uh, we have x plus a is minus y over y dash, and from here we can say that a is minus x minus y over y dash. So use these two values in the given y to get y equals a is minus x minus y over y dash, and what is x plus a? X plus a is minus y over y dash. Now
Yes,
we
sir. I
can
got the answer.
take the LCM on the numerator to get minus x y dash minus y over y dash, and we can uh, eliminate these two y dash
Cancel.
to get y square minus y square equals minus xy dash minus y. And if you rearrange this, you get the same equation, like it was a square. It got deleted, right? So this was our next question. Let's see one more to quickly solve this. So we have x square equals 2y square log y. So we have to show that. So we can differentiate. The first thing that I do is you can differentiate this and try to make this look like the differential equation that is given. Okay, so first approach is always this, and if this doesn't work, what you can do, you can differentiate and substitute the value of dy over dx, like replace this dy over dx that you get from differentiating this equation, and try to solve the left hand side of the equation and get what is on the right side. You have 0, so you have solved it to get 0. Okay, so let's try the first approach by differentiating and trying to make this like this equation here. So differentiate this to get 2x and this is 2 2y log y plus y square into 1 upon y dy over dx, and here also we get dy over dx because we are differentiating y with. Okay,
Yes, sir.
so what we can cancel these twos, and what we get x is y.
2y.
We differentiated y square, so we get 2y, and log y is just like that, and dy by dx is right. So y log y plus this y and y cancel out, and you get y, and I'm taking the dy by dx as common as it is present in
Common.
both the terms.
Sir, isn't it 2y log y?
Yes, 2y log y.
Yeah.
Okay, so now we have solved for x.
Yes, sir.
So now we have to now think that we have to make this equation look like this equation. So in the differential equation, there is no term which has log. There is no log term, right? So we
Yes, sir.
somehow have to reduce this log y. Now, how can we reduce this log y is by determine the given what was given. We can determine the value of log y from there.
Yes, sir.
Okay. So let's see. We have 2y log y, 2y log y, and what is the value of 2y log y? If you solve this, you get 2y log y as x square by y. I can write this like this now. 2y
Yes, sir.
log y is x square by y. So we can substitute the value of 2y log y here to get x square over y plus y is dy over dx. And this is the value of x. So now we can just do some calculations. X square plus y square over y dy over dx. And now cross multiply this x to get x square plus y square dy over dx equals xy, or we can say minus xy equals to 0, which is the differential equation here. Okay, so this is just one way to approach the problem. There are more ways in which you can solve the same problem. You can see we have calculated dy over dx here in the second step. So we can say that dy over dx is also equals to x divided by 2y log y plus y, right? We can determine the value
Yes,
of
sir.
dy over dx from here, and then what we can do, we can go in the differential equation and put the value of dy over dx, substitute the value that we determine in the second step here, and then we can solve the algebraic terms that we'll get, and we have to make this left hand side equals to 0, then only our equation will be verified,
Okay,
right?
sir.
So sometimes
Yes.
it depends on question that what's the best way to approach the problem, but both ways can be done, and the answer will be answer can be determined in both ways. So now let's head to exercise 8.2. I've covered most of the questions of the 8.1 in the questions that we discussed
Yes,
today
sir.
and yesterday, and some of the questions I have written in the assignment. So 8.1 will be completed, covered completely in that. So let's see what's 8.2. So do you have your book with you?
Yes, sir, I do.
Yeah, okay. So let's read question number 1. So what is the number of arbitrary constants in the general solution of a differential equation of order 4? So it's asking for the number of arbitrary constant in general solution differential. So differential equation is of order 4. Now let's see, if we have a differential equation of order 1.
Sir,
Let's see our differential. Yes. Yes.
1 second, sir. 1 second. I'll be
Okay, okay.
back in a second.
Okay, okay, okay. Let me know when you're back.
Yes. Yes, I am back.
Okay. So we have given a differential equation of order 4 and we have to determine how many arbitrary constants the equation have. So let's see if we have a differential equation of order 1 like this. So whenever we solve this equation, it's dy over dx. So we have to solve a differential equation, we have to integrate it, right?
Yes,
So
sir.
when we integrate it, since we are going to integrate it only once because the differential is only of order 1, we are going to get one constant only, c. Is
Yes,
that
sir.
correct? Now when
Yes, sir.
now consider a double order differential equation. So now when we want to solve this, we have to integrate it twice, because when we integrate d2y by dx2 once, we'll get y dash, and when we again differentiate it, we'll get y. So to reduce this double derivative, we need to integrate twice. So while integrating twice, we'll get how many arbitrary constant? We get two arbitrary constant.
Two.
We'll get
Yes, sir.
first in our first step when we'll integrate it once, and next step we'll get one more. So this is C1 and we'll get C2.
Yes,
So
sir.
the order of differential equation determines how many arbitrary
Arbitrary
constants
constants.
the solution will have. So here
Yes.
order is 4. So how many arbitrary constant must be present? 4 arbitrary constants
Four.
will be there. So next is, what is the number of arbitrary constant? So order 3. So we'll get 3 arbitrary constants,
Yes, sir.
right?
Yes, sir.
Verify that. Now we have a verify question like y is e raised to the power minus 3x, and the differential equation is y dash plus 3y equals to 0. Okay, so let's differentiate it once to get y dash is equals to minus 3 e raised to the power minus 3x, right? Now we can see that y was equals to minus 3x, and we have e raised to the power minus 3x here also. So we can do this, we can substitute y in
So
place of,
why?
yes, so we
Yes, sir.
get y dash plus 3y equals 0. So this is was our differential equation. So this, so you see, this was just one approach. Another approach can be, you can substitute the value of dy by dx. So the dy by dx is minus 3y. You can substitute it here to get minus 3y and plus 3y. So this must be equal to 0. Hence the equation is verified. So you can work the differential equations both ways. You can do these types of question both ways. Sometimes putting the value of dy by dx into the equation would be easier, and sometimes forming the equation will be easier. Here both the forming was way easier because we just have to do this. We don't have to substitute and then solve. So here we can solve by forming the differential equation more easily. So we have used this method. Okay, this is
Yes,
clear
sir.
now.
Yes, sir. Clear.
Okay, so let's see now fourth one. So first we have y equals x square plus 2x plus c. We have to show, okay, so we can just differentiate it once to get y dash 2x plus 2. And this is the equation that's given. The equation becomes y dash minus 2x minus 2 equal to 0. So this is the differential equation. So let's see next. So we have done this type of once more. The question 3 was almost similar, right? Y equals to
Yes, sir.
a e raised to the power minus x. So we'll just differentiate it once because there is only one arbitrary constant. So the equation needs to be differentiated only once. So y dash
Yes,
is
sir.
minus a e raised to the
Minus
power
a
minus
e to
x,
the power minus
and then
x.
a e
And
raised to the
a
power
to the
minus 6
power
y.
minus x.
Yeah, so we get y dash plus y equals to 0. So next is y equals square root of 1 plus x square. And okay, so let's make the differential equation here also. So we can write y dash as, what is the differentiation of root x?
Um, one
So
by
1 by 2 root x. So differentiation
two
of
root
root x is
x.
1 by 2 root x. So the
So it'll
differentiation of
be
root 1 plus x square will be 1 upon 2
one
root
upon
1 plus x square, and then
Yes.
the uh, by the chain rule we have to differentiate 1 plus x square also, so we'll get 2x.
Yes, sir.
Yes, so now we see we can substitute the value of y is
There.
what, root 1 plus x square here. This 2 and this 2 will
Yes.
cancel out, so we'll get, but it's not what was given in the differential equation. See what we are getting. So we don't have to actually do this, because the differential equation says what, 1 plus x square times y dash equals xy. So we have to solve for this. So we can see we'll get uh,
So, sir,
uh,
can't we substitute it
yeah, we can
there?
just substitute the value of y dash and solve. So you can um, in the differential equation you have term y dash which we have solved, a term 1 plus x square. So let's put the values on the left hand side to get the values of the right hand side. So what
Right
is
hand
1
side.
plus x square? What can we substitute in place of 1 plus x square? So here we see that y is equals to square root of 1 plus x square. So y square must be equal to 1 plus x square.
Yes, sir.
Right, we can say that y square is equals to 1 plus x square. So we can write 1 plus x squares y square in place of 1 plus x square.
Rice.
Next we have y dash. So y dash is x over and
Y.
x over under root 1 plus x square, right? Now
Which
we
is
can
also
again
Y, right, sir?
which is also y. So now we can write y squared into x divided by y, and this y cancel out, which gives xy in the left hand side, and the right hand side is also xy. So we have verified that this is the solution of the differential equation.
Yes, sir.
Okay, so let's do this last one also, because see this last one is different. So we have y is a e raised to the power bx, and the differential equation is y double dash minus b square y equals. So even if this differential equation was not given, you can see that the value of y contains two arbitrary constants a and b. So definitely
Yes, sir.
the first thing that comes to mind is you have to derivate this y two times to
Twice.
remove
Yeah.
these two arbitrary constants to get our differential equation. So let's do this.
Yes.
Differentiate once. So y dash is a b e raised to the power bx, and y double dash is a b square e raised to the power bx. And what is e raised to the power bx? What is a
Y
e
dash.
raised to the power
Oh, by
bx?
Y.
Yes, so y, so we get b square y, and this is y double dash minus b square y. Okay, so let's move on. So I think that I have given fifth question to you in the assignment. So let's just take a look. Show that the function y is ax plus 2a square is a solution of the differential equation. So here we have only one arbitrary constant. It does not matter how many times the arbitrary constant get repeated. The only thing that we are looking is number of arbitrary constants. So the number of
Yes, sir.
arbitrary constant here is only one. We have only a. So we are going to
Yes, sir.
differentiate this equation once to get something like the given differential equation. Okay, let's do question 7. So 7.1 says that y is e raised to the power minus x plus ax plus b, and we have to form differential equation. Okay, so there are two arbitrary constant here. We can see a and b. So we're going to differentiate this value of y twice. So differentiating
Twice.
once, we get y dash minus e raised to the power minus x plus a, right? And again differentiate, so we get y double dash as this minus and one minus again will come, so we'll get plus e raised to the power minus x, and this is 0, so no need to write that. So here now we can see we are free from arbitrary constant, so this is the required differential equation. You can also write it like this. Suppose there is a multiplication of 1 here, so you can multiply both side by e raised to the power x to get e raised to the power x y double dash equals e raised to the power x e raised to the power minus x. And here the exponent, the base is same, so power will get added, so you get e raised to power
Added,
0, and this is
which
just
is
1.
1.
So this is our required equation. So let's see eighth one. Eighth one looks a little bit difficult. Let's see. So eighth one is y is 2 times x square minus 1 plus c e raised to the power minus x square. So we'll do the same thing again. We'll make the differential equation from the solution. So here we can see there is only one arbitrary constant c. So we're going to differentiate this only once to get
Once.
y dash. So you get 2 times 2x minus 0 plus uh, let's give some space c e raised to the power minus x square. Now we're going to differentiate minus x square to get
Minus
minus 2x.
2x.
So let's simplify this 4x plus minus 2x c e raised to the power minus x square. So what is the differential equation that we're going to make? Dy by dx plus 2xy plus 4x cube. So we're going to eliminate c as well as e raised to the power this term. So let's see y dash. So here what we can do is we just have the value of y dash. Why don't we just put it in the equation? Let's this time. Okay. The equation is y dash plus 2xy gives 4x cube. So let's solve the left hand side by substituting the values and trying to get the 4x cube term. So putting the values, we get y dash is 4x minus 2x cx e, wait, e minus x square. This is y dash, and let's plus 2xy. So we are going to substitute the value of y also, because you can see there is no other y here. So we have to substitute the value of y to solve it further. So the value of y is 2 times x square minus 1 plus c e raised to the power minus x square. So this stays the same, minus 2x c e raised to the power minus x square plus this comes out to be 4x 4x cube. And when we get minus 2, we'll get minus 4x, and 2x times this is 2x c e raised to the power minus x square.
So everything will get cancelled out except for
Yeah, so everything
4x to
is
the power 3.
cancelling and just 4x cublets. So we'll do this. We can do this the first way also by forming the differential equation, or we can just do like this also. Okay, whatever method chooses suits you best, you can go with that method.
Yes, sir.
So we are done with question number 8. So you can do ninth in the assignment. I know I have put it there. So let's do question number 10, which is the last question of this exercise. So this is just the beginning of the differential equation. So some of the question might seem a little easy, but as the differential equation, as we move on to the part where we have to solve the equations, there will be some more difficulties. So let's do 10th. Y is c e raised to the power minus x cube, and we have to let's say we have to make a differential equation. So we see that there is only one arbitrary constant c. So we'll differentiate this once to get y dash and we'll get minus 3x square c e raised to the power minus x cube. And what is this? This is just y. So we can say that y dash plus 3x square y is 0, which was the equation that we have to made. Also determine the solution curve of the differential equation that passes through the point 0 comma 5. Also determine the solution curve. So we have to determine the solution curve that passes through an exact point. Like we are given the solution. What is the solution? The solution to this differential equation is y equals c e raised to the power minus x cube. But which type of solution is this? This is of the type general. This is the general solution, right? Because
Yes,
we
sir.
have the arbitrary constant present here. Now what the question is asking? The question is asking for particular solution, because it wants the solution that passes through 0, 0 and 5, right? So it's asking about a particular point. So in this case we are
Yes,
going
sir.
to determine the particular solution. How can we determine the particular solution? We can satisfy the given point in this y and solve for c. Whatever c comes out, we can then replace the c here to get our particular solution. Let's do this. The point is 0 comma 5. So this tells us x is 0 and y is 5. Let's substitute. So y equals to 5 gives c e raised to the power minus, we'll say that it's all is 0 because 0 to cube is 0. So we get c as 5, right? The value of c is 5. So what we can do, we can just remove c and put 5 to get y equals to 5 e raised to the power minus x cube, which is the particular solution because we don't have any arbitrary constant present now.
Yes, sir.
Okay, so this was the exercise 2. So do you have any questions till now in this exercise?
No, sir. Not yet.
Okay, so let's move forward. So next is also the same thing that we are doing, formation of differential equations. So while confirming that whether a given value of y is a solution of the differential equation or not, we are doing the same thing. We are somehow forming the differential equation from the given value of y. So same we have to do here. So what does formation of y like says? That if you have a function of the type x, y, c1, c2, you have to do some operations, differentiation, and make a differential equation which is independent of that c's. Like you have to make a differential equation, you have to remove arbitrary constants, arbitrary constants to get something like this f dash xy. Okay, in the differential equation, there shouldn't be any arbitrary constant present. And when that step happens, we'll say that the we have formed the differential equation. Okay, so let's
Yes, sir.
see our first example here, which is given as a curve is given as y is cx plus c square. Now we have to make a differential equation representing this curve. So this is what? This is a linear curve. Y is cx. So this must be something like linear curve. So we have to determine a differential equation which represent this linear function. So what we need to do, we need to somehow remove this c's from the y. So let's
Yes,
differentiate
sir.
it once. So we get dy by dx as c, only c, right? So wherever we see the written c here, we can just substitute dy by dx. So we get, substituting the value of dy by dx in the curve, we get y as y dash x plus y dash square, right?
Yes, sir.
Now we see that the c is now not present here. So this is the required differential equation that represent this family of curves. Y is equals to cx plus c square. So we are doing the same thing in the previous exercise. It's like the same continued. Here you'll get some more the some more curves like circle, like ellipse. So you have to find the differential equation representing these curves also.
Yes, sir.
So let's do some of the questions, then move on to the exercise. Yeah, so this one is pretty unique. Let's see. Y square is x minus c whole raised power 3. So we have to make a differential equation out of this curve. So first step is same differentiating. We get 2y dy over dx gives 3x minus c raised to power 2. Now, how can we like form the differential equation? To form the differential equation, we need to replace this c, right? We have to
Yes,
remove
sir.
this arbitrary constant c. But how can you do that? So there can be multiple ways. Like you can expand this, and you can expand this to get, you can substitute the value of c from here into here to get, something in terms of y. That's one possibility. But the most efficient way here to do is, you see that both terms are both have x minus c. So what if instead of removing just c, we remove whole x minus c? Because that is doing that is easy. How we can do that? Just divide both of these equations, and before that try to make this exponent same. So how you can make 3 and 2 same? What you can do, you can take the square of equation 1 and take the cube of equation 2. So squaring first term, what we get y4 and x minus c whole power 6, right? When you square
Yes, sir.
the equation 1, the powers will multiply it, and when you cube the equation 2, you will get 8y cube dy over dx whole power 3 gives 27, 27x minus c whole raised power 6. So now we have same term x minus c. So we can just substitute the value of x minus c here, or we can just divide both of these. Like substitution is more feasible, so let's just substitute it here to get 8y cube dy over dx 27y4. So this y3 and all the y's powers will get cancel out, and you get 8y dash whole cube is 27y. So this is our differential equation.
Got it, sir.
Yeah, so this is what. So now let's move to the exercise and do some of the exercise questions. Or we can just recap all that with what we learned today. And I have given some assignment. Let's see that. So these are all the questions that I could find out. And
Yes, sir.
first one is order and degree. Second one is you have to check whether a solution, whether a given value of y is a solution of the differential equation. And let's see. Yes, so there are some more.
So when should I submit this?
You can submit it by end of the week.
End of the week. Okay.
Yes, because we'll have some we'll have a class tomorrow also. What was our schedule? Let me check.
Sir, I thought it was Saturday.
Yeah, that was Saturday. So it will good if you can submit it just before Saturday's class,
Yes, sir.
right?
I'll
So
submit it
that
on
I
Friday.
can, yeah, I can check it, and we'll discuss if you have some problems in the assignment
Yes.
questions.
Sir, also I wanted to inform you that I don't have any trigonometry based questions.
Okay, that was removed part of the syllabus, right?
Yeah, because it's applied maths, we don't really have trigonometry.
Okay. So okay, okay. So in your book also, I see there are not some very trigonometry based questions.
Yes.
We're going through by your book also. So whatever's in the given unit, we'll just cover those. And
Yes, sir.
I will remove the deleted part which is like removed, so we can only focus on what's coming in the exam.
Yes, sir.
Right. So please let me know by Saturday if you have any queries, and
Yes, sir.
please
Sure.
try to do all of this, all of that we have done today by yourself also, because you see the amount of questions that you do will be directly proportional to how much you can learn,
Yes, sir.
right? To learn more, you have to do it by yourself. So
Yes, sir.
take all of the questions that you can find, and just uh, do all of that. Okay,
Definitely, sir.
until you reach a point where you can like see any question, the topic that we have learned, you can see any topic, you can see any question, and you feel like, yeah, I'm confident, I can do this. So that is where we have to reach. Like after covering a topic, after going through it, you have to be sure that whatever is asked from that topic, I'll definitely cover it.
Yes, sir.
Okay, so we'll close the class today, now, and we'll meet on Saturday next, right?
Yes, sir.
Okay. Okay, nice to have you. Bye bye.
Thank you so much, sir. Bye bye.
Thank you.
Thank you, sir.
Why it's not showing?